In section 6.4, we're going to talk about rational exponents. So just a kind of a quick recap here, we're just going to kind of work with rewriting expressions that have like a fractional exponent to have them with a radical. So 216 to the 1/3 power could be rewritten as the cubed root of 216. Also, let's say we have a question like this, where you have 7 to the 1/2 power times 7 to the 1/2 power. When I'm multiplying two expressions together, I can add their exponents. So that leaves me with 7 to the 1/2 plus 1/2, or 7 to the 1st power. My final answer is just 7, which makes sense because this is basically just the square root of 7 times the square root of 7, which we know is the square root of 49, which is just 7. These are more kind of the general rules here, so I definitely make sure you have these written down. A to the 1 over n is the same thing as saying the nth root of a. A to the m over n power is the same thing as saying the nth root of a to the m. So let's look at another example here. What are x to the 3/7 power and y to the negative 3.5 power in radical form? So again, I want to rewrite these with the radical in it. X to the 3/7 power, I'm going to use that 7 as my radical, so this is going to be the 7th root of x to the 3rd power. And I'd be done. That's all I'd have to do here. Now, y to the negative 3.5, I'm going to have to do a couple things, and then some weird things happen beyond that. So this ends up weirdly being kind of a longer problem. Y to the negative 3.5, first I'm going to rewrite this as a fraction. So y to the negative 7 over 2. Since I have a negative exponent, I'm going to put this in the denominator. And that's always going to hold true. You're going to see that in the general rules that we do in the next slide here. So now I have 1 over y to the 7 over 2 power. To rewrite this as a radical, I could rewrite this as the 2nd root or the square root of y to the 7th power. And now, kind of leading into what we talked about yesterday, I can't have a radical in my denominator. So now, I'm going to rationalize the denominator, leaving me with the square root of y to the 7th over y to the 7th. Finally, I'm looking at this and I think, okay, y to the 7th seems kind of high. Is there anything I can pull out of this that would come out of a square root? I could rewrite this as y to the 6 times y. This pulls out, and I'm left with y to the 3rd power times the square root of y over y to the 7th. Finally, y to the 3rd, y to the 7th, I could subtract those and cancel out some y's there. My final answer here would be square root of y over y to the 4th power. So I kind of like this problem because it like weirdly ends up covering like everything that we've talked about so far with exponents and rational exponents. So yeah, so that's your final answer there. And let's move on. So here are the general properties of rational exponents. Definitely make sure that you're writing these down, you highlight this, you star it. This is going to be a good home base to come back to as we're working with rational exponents. If I have two expressions, a to the m times a to the n, remember I add the exponents together when I'm multiplying. When I'm taking a power to a power, so like a to the m to the nth power, in this situation I multiply my exponents. If I have two expressions that are taken to the same power, you could think of it like I'm distributing that power. So ab to the m power could be rewritten as a to the m times b to the m. As we talked about a little bit in that last slide, a to the negative m, or if I have a negative exponent, I put that in the denominator, that makes it positive. So a to the negative m can be rewritten as 1 over a to the m power. If I'm dividing two expressions, I subtract the exponents. And finally, if I have just an expression with a numerator and denominator to an exponent, I distribute it to the numerator and denominator. So a over b to the m power could be rewritten as a to the m over b to the m. So let's end this by looking at two more examples. Here, I want to simplify the 4th root of x to the 3rd over the 8th root of x squared. And normally, if I'm looking at that, I would think, okay, I can't simplify this at all. These are being taken to different roots. But if I rewrite this a little bit, I might be able to work with my fractions here. So I'm going to rewrite both the numerator and denominator with a fraction exponent. So it could be rewritten as x to the 3 over 4 power over x to the 2 over 8 power. And as we talked about in that last slide with our general rules, if I'm dividing two expressions, I can subtract their exponents. So now I'm left with x to the 3 over 4 minus 2 over 8. 2 over 8 simplifies 1 over 4. Now this is pretty simple because these have the same denominator. Left with x to the 2 over 4, or x to the 1/2. So my final answer here, simplified, is the square root of x. So that ugly expression, the 4th root of x to the 3rd over the 8th root of x squared, is just the square root of x. Finally, last problem we'll do today is I want to simplify negative 8x times the square root of xy all taken to the 2/3 power. So this is going to kind of use a lot of the stuff that we talked about with the general rules here. What I'm going to do first is, since I already have a fractional exponent, I'm going to kind of keep everything consistent. So all I did here is I rewrote out that square root as xy to the 1/2 power. This will just kind of make it a little bit easier to work in that 2/3. Now, I'm going to kind of distribute that 2/3 to every term here and move on from there to get out that first parentheses. So I have negative 8 to the 2/3 power times x to the 2/3 power times xy to the 1/2 to the 2/3 power. Now from here, if I'm taking to a power, I multiply. So 1/2 times 2/3 gives me, or just simplifies to 1/3. Then I kind of like distribute out that 1/3 to both terms in the parentheses. So I'm left with x to the 1/3 times y to the 1/3. And now I can simplify like terms. The x's here are going to combine. Here I would add my exponents. 2/3 plus 1/3 gives me 3/3, or just 1. And now finally, to deal with that negative 8 to the 2/3, I would just plug that in my calculator. Also remember when I'm plugging that in, remember parentheses here. Negative 8 to the 2/3 gives me 4 times x. Y to the 1/3 can be rewritten as the cubed root of y. And finally, I'm done.